All right, let's dive in. Today, we're going to put on our architect hats and figure out how to build an absolute fortress around one of your most critical cloud assets, your Azure storage.
So let me ask you something right off the bat. Is your cloud storage a vault or is it a sieve? It's a really simple question, but the answer is crucial. Because right now, valuable data could be leaking out without you even realizing it. And the line between the two is way thinner than you might think.
Okay, so for this explainer, I want you to imagine you're in the driver's seat. You are the security architect. You've just been called in to assess a live Azure environment, and your mission is simple, but it's urgent. Find the weaknesses and design a blueprint to fix them fast.
So our security review kicks off with a methodical scan. We're not looking for some super obscure zero-day hack here. Nope, we're hunting for the common, everyday risks that, honestly, are so often overlooked.
The scan is running, and yep, the first results are already popping up. This is kind of the detective phase, where we start to uncover the vulnerabilities that pose a real, immediate threat.
And there it is, our first major find. A blob container is set to public. Now what does that mean? It means anyone, literally anyone on the internet with the URL can see what's inside. No password, no authentication, nothing. It's basically the digital version of leaving a filing cabinet wide open on a busy street.
And when you put them side by side like this, the danger becomes crystal clear. Public access is anonymous and completely unrestricted. It's a massive risk. Our goal always is private access. That means it's restricted, it requires authentication, and it's secure. It's really the difference between shouting your secrets in a crowd and whispering them to a trusted friend.
Okay, next up. The scan is flagging another huge issue. We've found virtual machine disks that have sensitive data just sitting there without proper encryption. This is bad. It means if an attacker ever got access to the underlying storage hardware, all that data would be completely exposed.
And really, this quote just says it all. Encryption isn't some nice-to-have feature, it's an absolute must. Unencrypted data is, plain and simple, a data breach just waiting for a time to happen.
So we've found these open doors, right? But the next question is, how are people actually getting through them? Well, that brings us to the problem with keys. And in this environment, it's like the master key has been left right under the doormat.
And this leads to our third major finding. We've discovered that the shared access keys for the storage account are just lying around. Maybe they're in some source code or a config file. These keys are unbelievably powerful. And finding them exposed like this, that's a full-blown 5-alarm fire.
So what exactly is a shared access key? Think of it like a permanent physical master key to your entire office building. It can unlock every single door. If it gets stolen, the thief has full control and they have it forever, unless you go around and manually change every single lock.
And finally, we find our fourth issue. The applications here are using something called SaaS tokens, which can be good, but they're configured all wrong. They grant way too many permissions, and they're valid for far too long. Sometimes, basically forever.
You see, a SaaS token is supposed to be like a temporary keycard with limited access. Like giving a visitor a card that only opens the front door for the next hour. But when they're configured badly, it's like giving that same visitor a keycard that opens every single door in the building and never ever expires.
Okay, the review phase is over. We've identified the 4 critical vulnerabilities. So now, as the architect, it's time to put down the magnifying glass and pick up the drafting pencil. We're moving from finding problems to engineering the solutions. It's time to build our fortress.
Our redesign is going to follow a really simple but incredibly powerful 3-step plan. First, we're going to isolate the storage from the public internet. Second, we'll lock down identity to make sure only the right people get in. And third, we will get control over how all those temporary keys are granted. Network, identity, keys. That's the plan.
And here's where the blueprint really comes together. We're going to map every vulnerability we found to a specific fix. For those public blobs, we'll use private endpoints. That pulls our storage completely off the public internet. To get rid of those exposed shared keys, we're switching to role-based access control, or RBAC. For the weak SaaS tokens, we'll replace them with ones that are short-lived and only have the permissions they absolutely need. And for encryption, we'll upgrade to customer-managed keys, which gives us total control.
And let's just double-click on RBAC for a second, because it is an absolute cornerstone of this whole security design. It's all about the principle of least privilege. So, instead of giving everyone a master key, you give each person or application only the specific keys to the specific rooms they need to do their job, and absolutely nothing more.
We've reviewed the scene, we've designed the fortress. Now, let's distill this entire process down into a practical, simple checklist that you can use. These are your final takeaways for turning a vulnerable environment into a secure one.
Okay, here it is, your go-to checklist. Number 1, always disable public blob access. 2, use private endpoints to wall off your network traffic. 3, enforce RBAC for everyone and everything. 4, use customer-managed keys, especially for sensitive data. 5, only generate short-lived, least-privileged SOS tokens. And finally, and this one is crucial for maintaining security, set up proper logging and monitoring so you can actually see what's going on.
And that brings us to our final thought. Building the fortress is absolutely the critical first step, but security isn't just a one-time project. You've architected a secure state, which is great, but are you actively watching the gates? Are you monitoring the logs and alerts? Because a fortress, no matter how strong, is only as good as the guards who are watching it.